All right, we've talked about sine and cosine. We've talked about tangent and cotangent. We've got to talk about secant and cosecant. Here's the good news. Secant and cosecant are just building off of sine and cosine. These are actually pretty easy. Okay, once you get sine and cosine down, you're good for secant and cosecant. And that is because, so here we have secant of x, remember, is 1 over cosine of x. So let's look at this graph. This blue graph here is just our cosine, basic unshifted cosine, right? Starts at 1, crosses at pi halves. Here it's at -1, at 3 pi halves, and then at 2 pi we're back, right? It has period of 2 pi, just goes up and down forever, right? All right, so 1 over cosine of x, well, it's going to have asymptotes where it's 0, right? So that's going to happen at pi halves, 3 pi halves, negative pi halves, negative 3 pi halves, so go on forever, okay? And here's the nice thing. So here's how we graph a secant. We graph cosine, we draw the vertical asymptotes where it crosses the x-axis, and then we just draw these little u's. Okay, so let's make a few observations. What's the period of secant? It's going to be 2 pi, right? Because we would need this part and this part to make a stamp that we could just go on forever. So secant has period of 2 pi. Everything else, we literally just draw cosine, draw these little vertical asymptotes, and then draw these little u's, connecting, just touching at the maximum and minimum of cosine x, okay? Secant or cosecant is the same, except, remember, cosecant is 1 over sine of x. So instead of drawing a cosine graph, we draw a sine graph. And everywhere that the sine graph is 0, right, we're dividing by 0 for cosecant, so we're going to have to draw vertical asymptotes at 0 and at pi and at 2 pi and so on forever, right? And then same thing, we just draw these little u's that touch the max and mins of sine. Okay, so again, period of 2 pi. If you think about it, this actually, both the sine, cosecant, and, no, that's not true. Do they have symmetry? Well, let's look at this one. This one definitely doesn't have vertical symmetry, y-axis symmetry. So this isn't even. Is it odd? Well, sine is odd, and so is cosecant. If we rotated the whole thing 180, or if we folded it twice, it would match up. So cosecant, just like sine, is odd, and secant, just like cosine, is even, right? If we folded this along the y-axis, it matches up, okay? All right, so let's practice. F of x equals 2.5 secant of 0.4 x. All right, so here's the first thing we do. Pretend it's just a cosine graph. So I'm just actually going to write cosine of 0.4x. Okay. All right, so let's graph this. Well, let's see, that has amplitude of 2.5. And what's the period? Period is going to be, for cosine, remember the period is 2 pi. So 2 pi divided by 0.4. I'm going to write 0.4 as 4/10. So I'm going to say 2 pi times 10 over 4. And let's see, this cancels with that to a 2. This becomes a 5. So this is equal to 5 pi. Okay, so my period is 5 pi. Okay. All right, so let's graph cosine. It's going to go up to 2.5 and down to minus 2.5, right, because of the amplitude. It's going to, here at 5 pi, complete a full cycle. So this is going to be 2.5 pi. Starts up high. Halfway through, it's down low. Here it's up high. Halfway through here, I don't want to figure out that value. It's going to go like that. And let's do 2 periods. So let's go back over here to minus 5 pi, minus 2.5 pi. Halfway through, it's going to look like that. Okay, so we've graphed cosine. Now, oops, we look everywhere it crosses, where cosine is 0, we draw little vertical asymptotes. because for secant, that's where we'd be dividing by 0. Okay. And now we say, okay, between these two vertical asymptotes, here's a min value. So my secant is going to look like that. Here's a max. So my secant is going to look like that. Here's going to look like that. And it's going to go on forever. Okay, so this is no harder than if you know how to graph your cosine and sine, you know how to graph secant and cosecant. You're home free. Okay, let's do another one. And we could just compare this. All right, what about this one? It's going to be a little more complicated, but again, no more complicated than cosine. So here's I wrote the equation out. So here we have amplitude. So let's first write this as cosine, and I'm going to factor out a pi thirds. So this is going to be minus 1/6. Is that correct? No. It's going to be 3/2. Is that right? Yep. Pi thirds times x is pi thirds x. Pi thirds times 3/2 is negative pi halves. Yep. Okay, so let's put this all together. So our amplitude is 4. We don't have any vertical reflection, so that's lovely. Our period is going to be 2 pi divided by that value there, by pi thirds. So 2 pi over 1 times 3 over pi is 6. Our period is 6. Our horizontal shift is 3/2 to the right. All right, since we have x minus 3/2. And our vertical shift is up 1. It's kind of a lot to put together. But we can do this. All right, our period is 6, and we're shifted 3/2 to the right. So we're going to start here at 3/2, and we're going to go over to 6. Well, no, we're going to go over to 7.5, right? If we shifted 6 over, it's going to be 7.5, or let's see, what is that? 15/2. So that's going to be one period. Halfway between that, let's see, 15/2 minus 3/2 is 12/2, which is 6. So half of that is 3. So if we add 3, that's going to be 9/2. Is that right? We'd go 6 here and 6 there. Yep. Okay, there's 9/2. There's halfway through. Okay, our amplitude is 4, but we're shifted up by 1. Okay, so normally we would be going from -4 to 4, but we're shifted up by 1, so we're going to be going from -3 to 5, right? And we're going to start here at our max, and then end here at our max, and then halfway through we'll be at our min. And so let's just connect that. It's going to look like that. And let's make our vertical asymptotes wherever this crosses the x-axis. And we know this is going to look kind of like that. So our secant is going to look something like that. So one thing to notice is maybe make your y-axis a little bit longer. You kind of run out of space if you're drawing these by hand. So on your homework, there's going to be things you can do online. I want you to be able to do this on paper, because on your test is on paper. Okay, so I want you to be able to graph these by hand on a piece of paper. So think about that as you're doing your homework. Make sure that you practice actually graphing these on paper. And let's look at what we got. There we go. Looks pretty much like what we had. All right, let's do, I think we have 2 more to do. -3 cosecant of 4x. All right, so I'm just going to write this as -3 sine of 4x. All right, since sine and cosecant are inverses. So this is what I'm going to graph. Amplitude 3, there's a vertical reflection, and a period of 2 pi divided by 4, which is pi halves. Okay, no shift, so that's nice. Oh, look, I didn't. Look, I haven't written too much. There we go. Now you can see everything I wrote. Okay, all right, glad I saw that. Let's graph this. So amplitude is 3. There's no shift, so we're going to go up to 3 and down to -3. Our period is pi halves. So halfway through is pi fourths. And this is sine, right? So we're going to start here. Halfway through we'll be back at 0, and the end will be back at 0. And then here, oh, except, wait, it's a vertical reflection, right? Normally we'd go up and down, but this is a vertical reflection, so we're going to be down and then up. So it's going to look like that. Yeah? So again, we have our 5 points, 1, 2, 3, 4, 5, that kind of make this sine curve. And we could draw another one. This was, if we went up to pi, and this is 3 pi fourths, right? Here would be at the negative, here would be up here. Oh wait, that's not right. So there's our sine graph. Now we draw vertical asymptotes. And we draw our little U's that is going to be our cosecant graph. Okay. And there we go. One last one. 2 cosecant pi halves x plus 1. Let's do this one. All right, so again, we've got sine. So I'm going to write this as y equals 2 sine pi halves x plus 1. So our amplitude is 2. No vertical reflections. Our period is 2 pi divided by pi halves. So 2 pi times 2 over pi. We could write this as 1 if we wanted. So our period is 4. Our vertical reflection is up 1. Okay, so let's put this all together. Our period is 4, so we're going to go from 0 to 4. If we wanted to do 2 periods, here we are at 8. Halfway through, obviously, it'll be 2 and 6. Our amplitude is 2. So we're going to go up to 2 and down to -2, except we have this shift. So actually, we're going to go up 1, so it's going to be up to 3 and down to -1, right? And our midline is here at 1. So we're going to start here at 1, and we're going to halfway through be at 1, and at the end be at 1, and then go up and down. And then same thing here. We're going to go up and then down. All right, so this is a little bit different. Let's look at how this plays out. Let's look at their graph. Okay, we still make our vertical asymptotes where it crosses the x-axis, which makes things a little bit funny. All right. Again, cosecant and secant graphs are pretty obscure. You're not really going to use them except in a trig class, but here we are. So you do have to know them, but they pale in comparison in importance to sine and cosine.